It's resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Welcome students to this session. Welcome to S. Chand Publishing and S. Chand Academy. And this session we are going to start the new chapter, that is chapter number 4, Quadratic Equations. In the previous chapter we did progressions, Theory of Quadratic Equations is what we are going to do today. So first let us recap all the important theories. First of all, a quadratic equation which is ax square plus bx plus c is equal to 0, where coefficient of x square a is not equal to 0 is called a quadratic equation. Now this quadratic equation has two roots, alpha beta. So sum of the roots is minus b upon a and product of the roots is c upon a, and difference of the roots is mod of difference of the roots, that is positive value, root over d by mod a. From where do we get these values? If we see the roots after solving this quadratic equation, then alpha beta come out to be minus b plus minus root over d by 2a. What is d here? D is the discriminant, and discriminant is b square minus 4ac. So these formula we need to memorize, we need to know, and we have done this formula from class 10th only, so it is not a big deal. Now if you add alpha beta, you will get this. If you multiply, you get this. If you subtract and take the mod, you get this. Next, I am not going into the derivation of this quadratic equation and its formula of roots. I am coming to nature of roots. So if you talk about nature of roots, so alpha beta are the roots. If discriminant is greater than equal to 0, we say that the roots are real. And here again, if discriminant is strictly greater than 0, we say roots are real and distinct. And if we take discriminant equal to 0, we say that roots are real and equal, that is alpha and beta are same, overlapping roots, right? Another condition would be discriminant less than 0. So if discriminant is less than 0, roots are imaginary or complex roots with non-zero imaginary parts. Imaginary numbers we all know, we have studied in complex numbers. Now if we are being asked what is the graph of this quadratic equation or the quadratic expression, so y is equal to ax square plus bx plus c is the corresponding quadratic expression. If we equate it to 0, it becomes equation. Now if we take this one here, a graph like this, upward opening parabola, which is cutting the x-axis at 2 points. So these two are called the roots of this quadratic equation or the zeros of the quadratic expression. And this is the vertex whose coordinate is minus b by 2a comma minus d by 4a. D we already know is the discriminant of the quadratic equation, and this is the graph of y is equal to ax square plus bx plus c. Now under what condition we get this graph? As we can easily say that there are two distinct real roots, then it means that discriminant is greater than 0. So discriminant is greater than 0. Also it is an upward opening parabola. So if it is an upward opening parabola, the coefficient of x square, which is a, needs to be positive. And as you can verify also, a is positive, d is positive, so minus d by 4a is negative. That is why this vertex is below the x-axis, right? What other cases are possible? Like if you take the graph which is touching the x-axis, not cutting it but touching it. So if the graph is touching the x-axis like this, then that means that the roots are real and equal. Alpha and beta are same, and this vertex is still minus b by 2a, but actually d is 0. So minus d by 4a becomes 0. So why d is 0? Because it has real and equal roots. That is why discriminant is coming out to be 0. And a is greater than 0. Why? Because it is upward opening parabola. Now third case of upward opening parabola could be that the graph is neither touching nor cutting the x-axis. That means there are no real roots. Both the roots are imaginary roots. So in that case, a is positive and discriminant is less than 0. So this vertex is again minus b by 2a, comma minus d by 4a, and as you can verify, since d is negative, a is positive, so minus d by 4a is a positive value. So it is above the x-axis. Now since it is an upward opening parabola and it does not cutting the x-axis, we say that it has no real roots. So here real and distinct roots. If you talk about this first condition, if you talk about this second condition, you will say real and equal roots. And if you talk about this third condition, you will say non-real roots, which we also say imaginary roots. Now these are the three cases of upward opening parabola if the coefficient of x square is positive. But another case could be a coefficient of x square is negative. Coefficient of x square cannot be 0, because in that case it won't be a quadratic equation anymore. So you need the coefficient of x square as positive or negative. So in that case, if you draw the graphs, what type of graphs you are getting? When you take a less than 0 and d greater than 0, then the graph would be something like this. This is alpha, this is beta, two distinct real roots, and the vertex is still same, minus b by 2a, comma minus d by 4a. So if you see here, a is negative, d is positive, and there is a minus sign, so overall it is positive. So it is above the x-axis and it is the downward opening parabola. This point is minus b by 2a, that is the vertex of the parabola. This is called vertex, right? And these type of graphs we study in parabola chapter, also in coordinate geometry. So here again, if you see there are two distinct and real roots. Now if you talk about another case, that case would be a less than 0 and d equal to 0. What happens in that case? The downward opening parabola just touches the x-axis. So it is minus b by 2a, comma 0. And this is the equation of ax square plus bx plus c is equal to y. And since the roots are equal, alpha is equal to beta. And can you tell me what is the value of alpha and beta? So alpha and beta both are same and it is touching it at minus b by 2a. So this is the root. This is the real and equal root. It is real and equal roots. And if we talk about the graph which is neither touching nor cutting the x-axis, then in that case the coordinate will be minus b by 2a, comma minus d by 4a of the vertex, and the equation is y is equal to ax square plus bx plus c, and this is non-real roots, as it is evident from the graph also, since here a is negative and d is also negative. So minus d by 4a is negative value below the x-axis. Now what about the range? You can also see the range here in both the cases. In the previous case, as you can see, the value of y, the value of y here belongs to minus d by 4a to infinity. If you talk about here, the value of y belongs to 0 to infinity. From here, if you see, value of y belongs to minus d by 4a to infinity. That is the value of y, not the value of x. X is real. Domain is real number. Every value of x will give you some real value of y. But y will not always be obtained for any value of y. From here you can see that y is belonging to minus infinity to minus d by 4a. Here it is y belonging to minus infinity to 0, actually minus d by 4a is 0, and here y belonging to minus infinity to minus d by 4a, whatever negative value this is having up till that. So these are its range also along with the graph. So how many cases are there? 6 cases are there. 3 cases when a is positive, 3 cases when a is negative. In all those 3 cases, again we see one case of d positive, d0, d negative. Similarly here 3 cases, d positive, d0, d negative. Next what we see here is common root. So if a1 x square plus b1 x plus c1 equal to 0 and a2 x square plus b2 x plus c2 is equal to 0 has 2 common roots. They have 2 common roots. Then that means the coefficient of x square, coefficient of x and the constant are in the same ratio. Because they are overall the same equation, you will just take the constant out and divide it to 0. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. If you talk about one common root, then what happens? So let us suppose that common root is alpha. So it will become a1 alpha square plus b1 alpha plus c1 is equal to 0 and a2 alpha square plus b2 alpha plus c2 is equal to 0. Now let us solve them. So alpha square upon b1 c2 minus b2 c1 minus alpha upon a1 c2, cross multiplication is what we are doing here, a2 c1, and then 1 upon a1 b2 minus a2 b1. Now next case you can equate this to this. So alpha square will be equal to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. And if you equate these two, you will get alpha is equal to a2 c1 minus c2 a1 upon a1 b2 minus a2 b1. Now if you square this, that will become alpha square and equate it to this. That will be the condition for one common root. Okay. Now let us come to some of the questions of quadratic equations. The roots of the quadratic equation 8x square minus 10x plus 3 is equal to 0 are alpha and beta square, where beta square is greater than half. Then the equation whose roots are alpha plus iota beta to the power 100 and alpha minus iota beta to the power 100 is. So let us see. First let us find the roots. So 8x square minus 10x plus 3 is equal to 0. This implies 8x square minus 12x plus 2x plus 3 equal to 0. We are doing middle term splitting. So 8x common, not 8x will be common, but 4x will be common, right? So let us take 4x common, and this will be 2x minus 3 plus 8 into 3 24, so it should also be 6 4. So this splitting is wrong. This splitting is 6 4 splitting, not 12 2, because AC is not negative, it is positive. So we need to find addition, not subtraction. So for addition, the splitting will be 6 and 4. So plus 6x plus 4x plus 3. This implies 2x common, 4x plus 3 plus 1 common, 4x plus 3 equal to 0. When we do this, we get x 4x plus 3 common into 2x plus 1 is equal to 0. Okay, there are minus sign there, not plus sign. So here also we have done the error. So we have to take care of any careless mistake. Otherwise, the question will be wrongly solved, though we know the method. So it is very important to cross check the sign. So this is 4x minus 3, right? That will give you 8x square minus 6x, and this is minus 1. This is minus 1 again. So let me write it as minus 1 here. 8x square minus 6x minus 4x, that is minus 10x plus 3 equal to 0. So x is equal to 3 upon 4 comma 1 upon 2. So these are the two roots of this quadratic equation. Now they are saying that the roots are alpha and beta square, where beta square is greater than half. So which one of them is greater than half? This is not great. If you square this, will that be greater than half? 1 by 2 square is 1 by 4. 1 by 4 is not greater than half. But 3 by 4 is square. So 3 by 4 square is, let us check, 9 by 16, which is obviously greater than half, because 8 by 16 is 1 by half, 1 by 2. So this is actually beta square and this is alpha. So alpha is given as half and beta square is given as 3 by 4. Then what will be beta? Beta will be plus minus root 3 by 2. And obviously we take positive value here because already they are taking plus and minus in both the cases. So unnecessary, we need not take plus and minus on our own. So plus root 3 by 2 is okay. You can take minus also, there is no issue. So beta is equal to root 3 by 2 and alpha is equal to 1 by 2. Now quadratic equations has roots alpha plus iota beta to the power 100. So alpha plus iota beta 1 plus root 3 iota by 2 to the power 100, and another one is alpha minus iota beta. So 1 minus root 3 iota by 2 to the power 100. Now what is this? If you remember complex numbers which we did previous session, this is actually, if you observe or absorb minus sign in it. So this is actually minus omega to the power 100, and here this is actually minus omega square to the power 100. So this can be written as omega to the power 100 after absorbing the minus sign, and omega to the power 200. So these are the two roots. Omega to the power 100 is finally omega. Omega to the power 200 is omega square. As we know that omega cube is 1. So any multiple of 3 to the power of omega is 1. So finally, when we want to write the equation of omega and omega square, so you remember you need not solve it. Even if you solve it, you will get the answer. X minus omega square is equal to 0. This will give you x square minus omega plus omega square into x plus omega cube is equal to 0. So x square, omega plus omega square is minus 1. So this will become plus x, omega cube is 1 equal to 0. So which option? Option number B is the correct option. You should mention here, because cross referencing is important. Omega plus omega square is equal to minus 1 and omega cube is equal to 1 by complex numbers. Let us come to the next question. If alpha beta be the roots of ax square plus 2bx plus c equal to 0, and alpha plus delta comma beta plus delta be those of ax square plus 2bx plus c equal to 0. So here a, b, c are small, there a, b, c are capital. Then prove that b square minus ac by b square minus ac, in numerator they are in small letters, in denominator they are in capital letters, is equal to a by a whole square. So if you talk about this question, here the roots are alpha and beta. So here what we have to apply, sum of the roots, no, it will not work. Product of the roots will also not work. Difference of the roots will work, because difference of alpha beta is alpha minus beta, and difference of alpha plus delta and beta plus delta is also alpha minus beta. Delta delta will cancel. So this extra delta will vanish if we take difference of the roots. So let us take difference alpha minus beta here. So when we take alpha minus beta, it is equal to root d by a, that is root over b square minus 4ac by 2a, that will become root over b square minus ac by a. This is alpha minus beta mod. Let us put the mod here. For the second one, alpha plus delta minus beta minus delta mod is equal to root over b square 4b square minus 4ac by 2a, that is 2a. Delta delta cancels, alpha minus beta mod is equal to root over b square minus ac upon a. Now both these equations have alpha minus beta mod. So can we equate them? Of course. So therefore b square minus ac under root upon a is equal to under root b square minus ac upon capital A. Next step, we can square. So b square minus ac upon a square is equal to b square minus ac upon a square. Now for getting the desired result, what we can do, we can cross multiply. So b square minus ac by b square minus ac is equal to a upon a whole square. So this is what we had to prove. So we have finally proved it. Now let us come to the next question. If x equal to 2 plus 2 to the power 2 by 3 plus 2 to the power 1 by 3, then the value of x cube minus 6x square plus 6x minus plus 6x is. So this is a problem set 1 question, question number 35A. Please like and subscribe and share the YouTube Academy with your friends, and also hit the bell notification to get the notification of new videos. So as you can see here, this is x is equal to 2 plus 2 to the power 2 by 3 plus 2 to the power 1 by 3. So what you can do here is, let us write it as x minus 2 is equal to 2 to the power 2 by 3 plus 2 to the power 1 by 3. In the next step, I am going to square both the sides, or I am going to cube both the sides. So this will become x minus 2 whole cube. It is 2 to the power 2 by 3 plus 2 to the power 1 by 3 cube. This will be a cube minus b cube minus 3a square b, that will be 6x square, plus 3ab square 12x is equal to a cube plus b cube plus 3a square b. So 3a square b will be 3 into 2 to the power 5 by 3 plus 3ab square. So that will be 2 to the power 4 by 3. So this will become x cube minus 6x square plus 12x minus 8 is equal to 4 plus 2, 6, plus 3 you can take common, and also you can take 2 common from both of them. So this will be 2 to the power 2 by 3 plus 2 to the power 1 by 3. So we are coming to some conclusion. Just see what we have got earlier. We have got x minus 2 as this. Okay, so 2 to the power 2 by 3 plus 2 to the power 1 by 3 can be substituted as x minus 2. So what am I doing here is 6 plus 6 x minus 2. So this will be 6 plus 6x minus 12. This will be 6x minus 6. Now this is x cube minus 6x square, and 12x minus 6x will be 6x, is equal to 8 will go on the right hand side, 8 minus 6 will be 2. So was the question asking this value, x cube minus 6x square plus 6x? Yes. So this is equal to 2. You could have also solved it by cube root of unity concept, but you would have taken x is equal to 2 plus 2 into omega square plus 2 into omega. Cube root of unity is omega, and square of cube root of unity is omega square. And you know that this is 2 common, 1 plus omega square plus omega, which is equal to 0. So x is actually coming out to be 0. If I am not wrong, 2 plus 2 square, sorry, it is 2 square. So 2 square into 1 to the power 2 by 3. So this will be like this. Two plus 2 square, 2 to the power 2 by 3 it is, not 2 square, and 2 to the power 1 by 3 it is. 2 to the power 2 by 3 and 2 to the power 1 by 3. So this may also be written as 2 plus 2 to the power 2 by 3 omega square plus 2 to the power 1 by 3 omega, and then also you could have proceed, but this method is anyhow better method. Let us come to problem set 2, question number 4. If the equations x square plus ax plus b equal to 0 and x square plus bx plus a is equal to 0 have a common root, then the numerical value of a plus b is. So they are saying that they have a common root. In case of a common root, what we do? We use the formula for the common root. And what was the formula? I told you, don't remember it. You have to do in the problem as it comes. So let us suppose the common root is alpha. So that alpha will be satisfying this equation, alpha square plus a alpha plus b equal to 0, and another one alpha square plus b alpha plus a equal to 0. Now alpha square upon a square minus b square, cross multiplication, alpha upon minus alpha upon a minus b, and 1 upon b minus a. So what you get when you equate these two, you get alpha is equal to a square minus b square by b minus a, that will be minus of a plus b. And if you equate these two, you get alpha is equal to 1. So let us check alpha is equal to minus of a plus b. Does it satisfy the equation? This is a square plus b square plus 2ab. So a square plus b square plus 2ab. Then minus a square minus ab plus b. No, it is not satisfying. So you can't take alpha is equal to minus of a plus b. So because it is not satisfying the first equation. For alpha is equal to 1. So if you put alpha is equal to 1, 1 plus a plus b is equal to 0, 1 plus a plus b is equal to 0, and at the same time this equations also become the same. 1 plus b plus a is equal to 0. Yes, 1 plus b plus a is equal to 0. So this value of 1 is satisfying both the equations simultaneously. So numerical value of a plus b is actually coming out to be minus 1. Both will give you a plus b is equal to minus 1. Previous one you want to check, you can check further also. Don't cross it like this. What you can do is, let us check for both of them. Though we have got the answer, but for another one, let us check for both of them. Might be there would be some new thing which will come to us. So alpha is equal to minus of a plus b. So this was becoming a square plus b square plus 2ab minus a square minus ab plus b. So a square get cancelled, it will become equal to 0, which is 2ab minus ab is ab plus b square is equal to 0. So a plus 1 plus b into b is coming out to be 0. Obviously we can't take b is equal to 0, otherwise the equation will become x square plus ax equal to 0 and x square plus a is equal to 0, and in that case the second one will give not the real root, or it may create more problems. So from here also you are getting a plus b is equal to minus 1. So you can proceed either from here or you can proceed from here also. I am not going into much of this, but it is better to get deeply into a question and solve all the aspects to understand what other thing is hidden in it. Because this video lecture is for a finishing of all the concepts, and that is why we can't take too much of time for each question, but I will suggest you do practice as much as possible and go into the in-depth understanding of the question. Discuss the nature of the roots of the equations. A plus c minus b x square plus 2cx plus b plus c minus a is equal to 0. So here in this a, let us see discriminant. Discriminant is b square, that is 4c square minus 4ac, 4a plus c minus b into b plus c minus a is equal to, let us open, or before opening let us do some more manipulation, 4c plus a minus b, and here c minus a minus b. So this will become 4c square minus 4c square minus a minus b whole square. This 4c square will get cancelled and you will get 4a minus b whole square, which is always greater than equal to 0. So you can say that for this first one the roots are real, either real or distinct or real and equal. For second one, let us see discriminant. B square is a plus b plus c whole square. We need not calculate minus because minus square is plus only. Minus 4ac, 4b plus c into a. This is a square plus b square plus c square plus 2ab plus 2bc plus 2ca, and here minus 4ab minus 4ac. So minus 4ab minus 4ac. So this will become a square plus b square plus c square minus 2ab plus 2bc minus 2ca. So this is a plus b minus c whole square. Just see the arrangement of minus sign. 2ab minus 2bc plus 2ca. So you take minus common and minus square is plus. So this is how you can write it. This is also greater than equal to 0. So the roots are real. What about third one, C? It says 2a square plus b square x square plus 2a plus bx plus 1 equal to 0. So here again discriminant will be 4a plus b whole square minus 4ac. So 4 into 2 into a square plus b square is equal to. So when you calculate, 4 is taken as common, or you can take 4 inside also, 4a square minus 8a square, that is minus 4a square, 4b square minus 8b square, that is minus 4b square, and 8ab plus 8ab. So the formula says take minus 4 common, a minus b whole square. So this is always greater than equal to 0. So you can say that imaginary roots or if you take a and b same, real and equal roots, but not real and distinct. So these are the three cases which we have solved here. if x is real, show that x square minus x plus 1 by x square plus x plus 1 takes value from 1 by 3 to 3. So here you have to find the range. So in order to find the range, what we do, the expression which is given, I am going to take it as y. So y is equal to x square minus x plus 1 by x square plus x plus 1. Now I am going to cross multiply. This type of questions you may also see in function chapter. So yx square plus yx plus y is equal to x square minus x plus 1. In the next step, we take y minus 1, x square plus y plus 1, x plus y minus 1 equal to 0. Now try to understand, it says if x is real, that is input is real, then what is the range of y? So if you have made it a quadratic in x, it is still x is real. Now in this quadratic, if x is real, then what happens? Then that discriminant should be greater than equal to 0. So if x is real, the discriminant should be greater than equal to 0. And what is the discriminant? Y plus 1 whole square minus 4 y minus 1 into y minus 1, that is whole square. Now let us open. So this will become y square plus 1 plus 2y minus 4y square minus 4 plus 8y is greater than equal to 0. In the next step, minus 3y square, sorry, this is minus, this here is minus, not plus. So minus 3y square, 8y plus 2y is 10y, and minus 4 plus 1 is minus 3 is greater than equal to 0. Now this inequality we need to solve. How will we solve it? First let us take the minus sign outside. 3y square minus 10y plus 3, and obviously the inequality will reverse when you will multiply by minus 1 both the sides. Now do the middle term splitting. 3y square minus 9y minus y plus 3 is less than equal to 0. From here you take 3y common, so y minus 3 minus 1, y minus 3 is less than equal to 0. From here y minus 3 is taken common, so 3y minus 1 is less than equal to 0. Now this is a wavy curve method or algebraic inequality method. So how do we solve it? Do you remember? The zeros are 3 and 1 by 3. So plot 1 by 3 and 3. Now all the coefficients of y are positive. So this will work like this, plus, minus, plus. So graph may be something like this. It is an upward opening parabola for this one. It is also a quadratic expression. And as you can see, the y will be this region, minus 1, because we need less than equal to 0. So y belonging to 1 by 3 to 3. So it says, if x is real, show that this takes value from 1 by 3 to 3. So yes, this takes value from 1 by 3 to 3. You can also write like this, that x square, which is y minus x plus 1 upon x square plus x plus 1 is lying between 3 and 1 by 3. Now let us come to the next question. The value of b for which the equation x square plus bx minus 1 equal to 0 and x square plus x plus b equal to 0 have one root in common is. Now again one root common. So again I would suggest you to solve this question on your own, and if you would be able to solve it, then come to this, or even if you don't able to solve it, come to this slide after a pause and then see this slide. Okay, so the value of b for which the equation x square plus bx minus 1 is equal to 0 and x square plus x plus b equal to 0 have one root in common is. So we don't know what that root is, so let us take that to be alpha. So alpha square plus b alpha minus 1 equal to 0 and alpha square plus alpha plus b is equal to 0. Now this alpha is the common root. What we do next is we take alpha square like this minus alpha like this, 1 like this. So alpha square will be b square plus 1 minus alpha will be minus 1 minus b, right, and 1 will be 1 minus b, like this. So when we equate these two, alpha square will be b square plus 1 by 1 minus b, and when you equate these two, alpha will be 1 plus b by 1 minus b. Now square of this alpha will be like this. So therefore when we equate them, b square plus 1 upon 1 minus b is equal to 1 plus b whole square upon 1 minus b whole square. Now let us multiply them. First of all, we can cancel 1 minus b because b cannot be 1, otherwise it will not be defined. Then multiply. So 1 minus b minus b cube plus b square minus b cube plus b square, right? And on the right hand side, 1 plus b square plus 2b. So b square get cancelled, 1 get cancelled, you will get b cube on the right hand side, 2b plus b, 3b is equal to 0. Now b is not 0, because if b is equal to 0, this question will be very trivial. So let us take b square plus 3 is equal to 0. So b square is equal to minus 3. So b is equal to minus root 3 iota with a plus and minus sign both. So there is only one sign given, minus 1. So we will take minus 1 as the option. If in case plus 1 was also given, that would also be a correct answer. So these were some of the questions for the session, and I hope you have enjoyed and you will practice more and more to get better understanding of this. Thank you, students.